Morning, everybody. Okay, so we've been talking about bending. Let's see if we can't make this more reality and actually see how it works. So if I wanted to bend a piece of 040, so there's my 040 right there, and of course I'm bending it here in the shop, so pretty much everything that we've got in the shop for radius is going to be 1/8. So what I'd like to do is bend a piece of 040 over a 1/8 radius and end up with a 3-inch leg, just like this, on one side, and an 1.5-inch leg on the other side. So your typical L bracket. So just to prove that what I've been teaching you is in fact true, let's actually do it. So first thing we got to do is we got to work our way through the math, right? And so first step is, of course, MBR. Can we bend it, as Bob would say? The answer is, of course, yes. So 040 can bend around a 332. That's the minimum. 1/8 is bigger than that, so yeah, we can do it. Step 2, we got to find out what our setback is. So we find the center of our radius down here, which is where our bending break is going to go around. And so what we've got to do is we've got to find that setback in those two little corners there, right? So that we can know what's our flat length and what our bent portion is. And in fact, I forgot to label this, so I'm just going to quickly go FL1 and FL2, okay? And then our bend allowance right there in the corner. Okay, so we're going to go setback, and of course K doesn't really play into this because it's a 90-degree bend. K is 1. So we're going to go radius 1/8, 0.125, plus thickness 040, and in fact let's write that down, R and T. And my total, of course, is 165. We've done this a couple times. Okay, so the next question is we've got to find out what is the length of each of the flats. So flat number 1 is going to be 3 inches, because it says right there, minus our setback, which ends up with 2.835 as its length. Our second flat is going to be 1.5, because that's what it says there, minus my setback, 165. So I end up with 1.335. And so what I end up with is my piece of metal with my 2.835 here and my 1.335 here. And now all I got to do is I got to find out that bend allowance in the middle. So what do? I go back to the chart and I look at the chart. I look at the top number at the intersection of 040 and 1/8 radius, right? And so when I find that, the magic number is 224. So I've got all 3 pieces of information that I need. I got my flat 1, my bend allowance, and my flat 2. Add them all together, and what do you get? Well, 2.835 is flat 1, 1.335 flat 2, 224 is my bend allowance, for a grand total of 4394. So I need a sight line, and it's going to be 1335 because I chose flat 2 as my reference, flat 2, and a radius, so 146. Okay, so I've laid that all out here to show you. There's my bend tangent lines, the beginning and the end of the bend, my bend allowance in the middle, and my red line is my sight line. And so what I've done is I've transferred that all across to my piece of metal. My piece of metal, when we measure it, let's see if I can do this one-handed. Come on, let's open up. Here we go. And when I measure it right here, well, you can see that, pretty close, within 2/1000ths of an inch, okay? And again, that was cut in like literally 2 strokes of a file and I was there. Okay, so there it is. It's all set and ready to go. Let's actually see if when we put this in the bending break, it's actually going to work. Okay, so standard piece 040, I left the plastic on. I got my arrows to show which end goes into the bending break. And let's put it in the bending break. So again, what I'm doing, here I'm looking from above. What I'm going to do is bring this down close. And then what I want to do is when I look straight down over the end of the bending break, I want to just be able to see that red line. You can see the black line, you can see the red line. I want that red line just about there. So hold on a second here, I gotta pull this down and pray that that actually stayed. Did it actually stay where I wanted it? No, not really. Crap. Hold on. I can just barely see the bend sight line. So I'm gonna lock that down, and here I'm gonna go here and I'm gonna bend to about, there's 90. So there's about 98, 99 degrees. Oh, I got tons of, sorry, don't look at that because I got the wrong setback in here right now. So I'm gonna have to make do here, sorry. Okay, that looks pretty close to 90. Maybe just a hair off. Okay, let's pull that out. It looks pretty close to 90. Okay, so now the question is, did it end up bending right? Let's go have a quick look. I'm taking it back to where the vernier is, or the caliper is. Hold on a second here. Put it there. Okay, let's see here. Okay, like that. And what are we going to do? We're going to take this and, oh, can you see that? Yeah, actually you can see that, I guess, not too bad. Let's have a look. Oh, see, that's within, it's 10, 12 thousandths out. So, and again, that was probably just because, right there. So yeah, about 15 thou out. And so how about this side? How does this look? Yeah, and that's about, yeah, about 18 thou over, because the other side was shy. So that's almost dead on. So probably a little bit of an angle, but it's still pretty close. And so within spec easily, and so we can see where the math actually works to give us our final product. Okay, and so there it is, and there's a practical example. Let's do some more. Where do we go?